Okay, so this is where we left off. So you can use a reference point to determine if an object is in motion. Where is it in comparison to that reference point? So in this case, you could use this tree that's coming up as a reference point, or you could use this red uh, cushy thing as a reference point. You could also use a moving reference point. So like I said, you could use, this is how people determined the motion of the planets back in the day. Also, if you're driving down the highway, you can decide if you are traveling faster or slower than a reference point in terms of another car. Okay, so back to distance and displacement. The distance an object travels is the total length of the path they take. So you can think about that as like the actual number of steps, or like the total path length, really just like how far they are traveling distance wise, how far they're moving that whole distance. So this distance here is 26 miles. But you'll notice, like, as the crow flies, 1 and 26 are actually not 26 miles apart. But the distance, the path length, the number of steps that they're taking is 26 miles. Okay? Displacement, on the other hand, is just how far the ending point is from the beginning point. Not the number of steps, just like dot, dot, how far those two dots are apart from each other. So what these mysterious symbols mean is the change in x, the change in the position of the object, is the final position minus the initial position, is what that means. So yeah, so start and finish. So that displacement is not a full 26 miles, but the path length is, the distance is. So, yep, okay. Here's another way of looking at it. The path taken was like this, but the displacement was only this distance to this distance. So that could be like, yeah, like, I don't know, like a lot less than this one anyway. So the displacement is 0 if the object stops at the same place where it starts. So like as a planet is orbiting the sun, 1 year, as the Earth is orbiting the sun, 1 year after we start, we end up in about the same spot. So that is a displacement of 0. If the object stops ahead of where it started, then it's got a positive displacement. If it stops behind where it started, it's got a negative displacement. You could also say, talk about it in terms of the directions. The displacement is like 30 meters north, or, 10 meters to the left, something like that. So we can also calculate speed. Speed is distance divided by time. And using that equation triangle, we can figure out that distance is speed times time. Time is distance divided by speed. So here, sorry, it's getting late. Here are some of the vocabulary words that we can use to describe the motion of an object. So the speed is the amount of distance an object travels in a certain amount of time. And we can contrast that with velocity, which is basically the amount of displacement after a certain amount of time. So you can imagine that in this example, if a car drove from here to here in a certain amount of time, and if this car also started and stopped at that same time but traveled that same distance, this car would have to travel a lot faster to cover that same distance, right? Okay, so speed is the amount of distance an object travels in a certain amount of time. The average speed is the total distance an object travels divided by the total time it takes to travel that distance. So yeah, basically total distance over total time. So the example for that is like if you're on a road trip, you may travel an average of 45 miles per hour, but there may be times during that road trip where you're traveling 90 miles per hour and other times where you're traveling 25 miles an hour or where you're stopped. But on average, your speed is 45 miles per hour, for example. Then we have instantaneous speed, and that's the speed of an object at a particular time. So that's like as you're driving down the road and the police officers got their like speed gun thing, and they clock your time, that's an instantaneous speed. At that moment, I was driving 45 miles an hour, but on average, I was traveling 25, right? So at that instant, you were traveling a certain speed, okay? And the other example that we use for average versus instantaneous speed is a sprinter would want to know how fast they can go, what's their top speed, whereas a cross-country runner would want to know what their average speed is. How fast can they go on average over a longer distance? So velocity is the speed of an object and the direction that it's traveling, okay? So velocity takes into account the direction. All right, so here are the equations we can use for speed, distance, and time. Works just like what we've seen before, where we've got this equation triangle. So whatever thing we want to solve for, we cover it up. And then if the things are above and below each other, it's division. If they're next to each other, it's multiplication. So speed equals distance divided by time. Time is the distance over the speed. And distance is speed times time. So another way you can think about this is by looking at the units to help you understand the problem. So whenever you see meters per second, then that's going to be in terms of speed, or kilometers per hour, feet per minute, miles per hour. If you see the word meters, kilometers, feet, or miles, that's going to be distance. If you see things like seconds, hours, minutes, or hours, or days, or months, or whatever, that's going to be time. Okay, so those are the big ideas for the motion and speed unit. You got this.